punishment or reward.
Do it right and you get a reward, but do it wrong and feel the mathematical pain.
We're talking about artificial intelligence, machine learning. So, for us humans, once bitten, twice shy. Or, if we accidentally burn our hand on the flame, we stay away from hot things, but there's a cost for us. We might have a scarred hand forevermore. Or maybe we're psychologically scarred by the biting incident. And we might train a drone using pain as well. A drone that could be used to find injured hikers at night. And it learns to avoid obstacles because it's got a spiking neural network on board. And that spiking neural network spikes the closer it gets to obstacles. And surges in voltage increase the nearer it is. And so it's almost like feeling pain, and it can back off and go another direction. And ultimately it learns to travel in the dark, sensing its way. You might have noticed online pictures of people kicking robots or pushing them over. And then you thought, hang on a second, there's a man over there in the corner with a remote control. This is a bit of a swizz, but no, this is just a training exercise. Those robots are being controlled by remote control, but there's also an onboard neural network learning. Not like when we burn our hand in the fire and we've got a permanently scarred hand. For the manufacturers of the robots or the drones, it's mostly just economic cost. It's just all mathematics. If you remember in a previous video we talked about Brier scores. Well, that's called a quadratic loss function. It's quadratic because if you do really poor performance as a forecaster, you're punished more than if you're just a generally poor forecaster. If you can afford the repair bill, you can learn anything. And well, big tech, it can definitely afford the repair bill. What about reward? We've talked about punishment. Well, reward is where we get some of AI's superpowers emerging. Because if you can find a really strong reward signal, you can get a machine learning algorithm to really strongly do well. This is why AI is so good at writing code. This is why it's also very good at hacking systems. It's a brilliant cybercriminal. It's also why it's so good at mathematics. Those three things all have really well-defined outcomes. You either get into the system or you don't as a hacker. Prove the mathematics correct or not with a proof. And writing code, you were working against a compiler and against automated tests, and those things give great signals like it has worked or it hasn't worked. And the big money in AI apparently is becoming a reward engineer.
I now get why calculus and matrix algebra was so important.